Hello friends, welcome to Akul Mac Live and I am Chandrakant. And if you remember friends, last week we had a very good orientation about different kinds of cables. Most of us are used to certain kind of wires in our homes and the CEO of Toshniwal Cables, Mr. Naveen Toshniwal, actually gave us a lot of information about the other types of cable which are required for sensors and industrial activities. So today Naveen is joining us back again and he will show us, in fact, he is going to demonstrate what are the various differences between the types of cable and why industrial cables are so special. So without further ado, let's welcome Naveen to the show.
Hello, Chandrakantji. I hope all are well.
Everything is well, Naveen. We have sunny days started in India, I think, and you're joining us from Jaipur, so it's going to be hotter than usual, I believe. But I think our viewers would like to know the differences between the subtle differences between different types of cables that we have, because most of the viewers are aware of the wires, electric wires, which are used in our house wiring. So over to you, Naveen.
See, we are all very familiar with the electrical cables which are used for connecting our lights, fans, and electrical gadgets. But industrial cables are very specialized. They are customized as per client requirements, and they have some special features which I will try to explain today. See, what happens is that instrumentation or industrial cables, they will normally be carrying a very low voltage or low amperage signal. So in such cases, chances are that there will be electrical interferences from the nearby power cables which are actually carrying the electricity, because in an industry you will have various types of cables which are laid. There will be power cables also, and there will be instrumentation cables also. So in order to prevent these electrical interferences going into these instrumentation or industrial cables, we have to provide some special features in the cables, which I will show to you. So I hope this will give you an idea how it differs from the regular cables. See, now this sample I am showing you, I hope it is visible. Yes. So here you will see that this is a two core cable. This is one core and this is the second core. So this one is basically a thermocouple cable which is used for measuring temperature. It is connected to thermocouples to measure the temperature. So in this one, this black color, this color marking black of the core, this is the positive leg, and this one which is marked red, this is the negative leg. So it is a combination of positive and negative which have got different materials. These are not copper, these are different alloy materials. If they are joined together at one end and again they are joined at the other end, few meters or few kilometers away, then they will produce an EMF or voltage. So this EMF or voltage is proportional to the temperature difference between the hot junction and the cold junction. So this is how the temperature is measured. We had studied in class 9 to 12 a physical principle which is called the Seaback effect. When we join two dissimilar metals at two different temperatures, you will have an EMF or voltage generated, and this will be proportional to the temperature difference. So this is how we are able to measure the temperature of the particular item where we are measuring temperature, whether it is molten metal or whether it is temperature inside the boiler. So this is called uh, 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 we can say a thermocouple effect, where EMF is generated and we are able to measure the temperature through connecting the hot junction and the cold junction with dissimilar metals. Now I will go to the next point. See, this is carrying a very low voltage, say maybe 4 millivolts or maybe even lower than that. So there are chances that the electrical interferences from outside, from other cables, might try to penetrate inside and disturb the signals. So you will see that there is a metallic tape given over here. This metallic tape is called electrostatic shielding, and it is connected with an earthing wire over here. This is the earthing wire. Since this earthing wire is used for grounding or earthing the cable, so that any electrical interferences which are caught by the metallic tape here, they are actually grounded through this drain wire or through this earthing wire. So the signals are not distorted. The signals which are going inside in these conductors, they are not distorted. The electrical interferences are captured and grounded through this drain wire. Another feature I want to show is that this is a multi-strand cable. You will see that in one particular core, there are several strands, maybe uh, 10, 15, 20, or maybe 7, 8, depending on the client requirement. So these strands will make the cable very flexible. We can even have a single strand, but then there is a risk of getting a breakage if there is a mishandling of the cable, and the flexibility will be lower. So this is actually a multi-strand compensating cable which has got an insulation of PVC on each core, and then we have this electrostatic shielding as I explained for earthing, and then we have the outer covering which is the final PVC covering. Now again, this insulation can be of any material. It can be of PVC, it can be of polyethylene, it can be of Teflon or rubber. Again, it depends on the particular site application and where the client wants to use this cable. Another point I want to point out is that electrostatic interference is taken care by this shielding. There is another sort of interference in cables which is called electromagnetic interferences. So electromagnetic interference is reduced by twisting the cores like this. So this particular two cores which you see inside the cable, these are actually twisted inside. If we cut open the entire cable, then you will be able to see that the twisting is there inside. This twisting like this will help to prevent electromagnetic interference. So there are two types of noises, we call it in a cable, electromagnetic and electrostatic interferences. So these two are taken care by twisting of the pair and also by electrostatic shielding and grounding of the unwanted external interferences.
Uh, thank you for taking us back in time in our school days when we studied the thermocouple. So I think most of the people, whether they are in arts or humanities or commerce or science background, whatever they are doing today, I'm sure everybody has studied the thermocouple, and I don't want to explain that principle here. But I have one question. The thermocouple, which is the other end of the cable, depends on the temperature variation, and because of the material that is used in your cable, it will generate some electric voltage, which will then be interpreted as a temperature at the other end. However, it is traveling through and then it is reaching your meter, after some distance, for example. So, for example, if you're measuring the temperature outside your house, by the time it reaches the monitor from where you want to see the temperature outside your house, it will be about 10 to 20 feet. So, during the transit, uh, the physical temperature will have any effect on this sensor or your cable. Um, so this is a very foolish question, but I just wanted to ask you that if the physical temperature will also have some bearing on the reading that you're going to get from this cable?
No, it's not a foolish question. As a layman, you have asked a very good question. In fact, see, there are two junctions in a thermocouple. One is the hot junction and one is the cold junction. Hot junction is inside the particular boiler or furnace where we are measuring the temperature, and the cold junction of the thermocouple is outside the furnace. Now, when we are extending the cold junction of the thermocouple to the measuring instrument, it is actually the cold junction of the thermocouple which becomes the hot junction for the cable. And when it is extended to the measuring instrument, there it is actually the cold junction. So there will be a temperature difference between the cold junction and the hot junction. So that is what generates the EMF, and that EMF is proportional to the temperature. So this will depend on the type of thermocouple. There are various types of thermocouples. You have iron constantan, which can measure maybe 400 to 500 degrees. Then you have chromal alumer thermocouples, which can measure 800 degrees. Then you have platinum rhodium thermocouples, which can measure 1200 degrees and more. So there are various types and various ranges of thermocouples which are used to measure different types of temperatures, different levels of temperatures. Now, the most important point is that this particular conductor, which is being used inside the cable, they have to be of very good quality so that the EMF characteristics match those of the thermocouples. Because remember, in a thermocouple, the wires are very costly. They are the original chromal aluminum or platinum rhodium wires. They are actually very costly. But these wires which are used in the cable, they are of much lower cost, but the EMF characteristics are similar to those of the wires in the thermocouple, uh, whereby there is no error up to a certain range of temperature. Say up to 100 degrees or 200 degrees in the cold junction, there will be no error or very minimum error, which is prescribed by the standards. That may be plus minus 2 degrees or plus minus 3 degrees.
Thank you, Naveen, for answering that and clarifying this particular aspect of this cable. Uh, I have one more question before we get into fabrication of these some of these products. Um, the melting point of these cables is really the threshold of where it can deploy. So you mentioned about different types of cable which are used at different temperatures like 1200 degrees, 1000 degrees, etc., for different applications. However, if there are very high temperatures, what kind of cables that your company produces to handle something which is very very high temperature, something like 2000 degrees or upwards of that? Do you have some certain requirements or some clients who are asking for very high temperature cables?
See, practically speaking, there is no insulation which can withstand a temperature of more than 700 or 800 degrees centigrade. You just have mineral insulated cables which can probably go beyond this temperature, but they are not regularly manufactured in India. Still, these are being imported. See, now when we are talking of the temperature of 1000 degrees or 1200 degrees, it is actually the temperature of the molten metal which is inside the furnace, or of the superheated steam which is inside the boiler. In fact, whenever we are putting a cable, it is not inside the furnace or the boiler, it is outside. It is connecting the outside portion, the cold junction of the thermocouple, to the measuring instrument. So in that area, the temperature practically will never exceed, say, 300, 400, or in the worst case, 500, 600, or 700 degrees centigrade. So our company can actually make cables which can withstand up to 700 degrees ambient temperature. We call it ambient temperature or the room temperature. So these cables are never required to withstand a temperature of say 2000 degrees or 1500 degrees.
Okay, so my next question would be around the fabrication of these cables, and you already mentioned that these cables are very, very expensive. Obviously, when you mention these elements, you are referring to alloys of different types. So, when the client approaches your organization for a specific type of cable, which requires a lot of R&D and mixing and matching of different elements to create that alloy. Um, would you like to tell us how that process works very briefly? And what are the capabilities of Toshiba cables when it comes to generating different alloys for this purpose?
See, actually, we don't manufacture the alloys. These alloys or the conductors which are used inside the cable, these these we are buying as a raw material. So in fact, this is an alloy and this is an alloy which we are actually buying from our raw material supplier, and this forms our raw material for making the cable. What we do is we first have multi-strand conductors, we bunch it in strands in a bunching machine. Then we go to the extruder and we give this insulation on the conductors. This insulation can be of PVC, polyethylene, or Teflon, or any other as per client requirement. Then we go to the taping machine, whereby we are giving this wrapping of aluminum tape and this earthing wire. And then again, we come back to the bigger extruder for uh, extruding this outer sheathing or insulation on the cable. So actually these alloys we are not required to manufacture. That is a very specialized process. For that you have to have a different manufacturing setup altogether. Maybe that's a process of the backward integration in the near future. As of now, we are actually buying these wires. We are not making it in our factory.
So, having said that, if there is a company which requires a special type of uh, cable to be manufactured, in that case, your procurement department will have to raise a tender for that kind of cable, isn't it? Is this your approach, or you simply say that, hey, this is not we get in India, so we cannot manufacture? So, what is your general approach towards a new type of sensors which requires a different type of cable?
See, actually R&D is always a part of development, and we try as far as possible not to say that no, we cannot give you this item. We make our efforts and try to get proper sources who can actually make or manufacture specialized conductors for the client's applications. Of course, conductor is a very vital feature in all the cable, but the insulations also play a very vital role. What type of temperature it has got to withstand. Then again, there are some electrical parameters which have to be taken care of. Like for example, if we require to use a cable in a highly explosive area where there are poisonous gases, so there are chances of explosion when the current is going through the cable, because any current carrying conductor will generate some heat. And in that process, if the ignition temperature of that gas is reached in that heating, there are chances of explosion. So in order to minimize that heating effect, we may have to use a different type of insulation. For example, the normal insulation which we use is PVC. But if we use polyethylene, it will reduce the heat generating effect. It will reduce the capacitance and inductance levels in the particular current carrying conductor. There is whereby the end result is that the heat generation will be less. So these are very this is an example of a critical specialized application in some of the oil refineries and petrochemical plants which we try to cater to.
Excellent. So this brings me to the last question today. I think we covered the uh, cables that your company manufactures, especially which connects the thermocouple. So my last question is related to basically testing of the raw material that your supplier is providing. because supplier, I mean, you may go back to your supplier saying that, hey, I need this type of cable which is made of this particular alloy, and he may supply something to you. Before you accept the consignment, the testing has to be done, whether he has given you the right material or not. So how do you do that in your company?
Yes, we have to do testing right from the raw material stage, intermediate stage, and then again the finished stage. So we have got chemical, physical, and mechanical testing equipments for all the raw materials which we get, not only the wires. First, we have to check the resistance, then the thermal EMF characteristics of the thermocouple cables, then how is the tensile or elongation strength when we apply force at both ends, how much force it can withstand before breaking. So these tests are all prescribed in the relevant international and Indian standards. So we test all these raw materials based on these relevant standards. Only then we accept the raw materials and start our production. And similarly, in process inspection is done. There is a test called a spark test. When we are extruding the wire, we pass it through a very high voltage zone where you are applying 6,000 volts for a small duration of 1 second. So if there is any fault or there is any weakness in the insulation, then there will be a spark. So that portion will have to be repaired later on before the process goes further. So this we will discuss in detail probably in one of the next sessions. But I hope this will give you an idea about the testing, which is the most vital from the raw material stage right up to the finished stage.
Absolutely, Naveenji. It was a very, very interesting discussion, and I'm sure viewers of this video will be able to appreciate, how they can, they can see the temperature in their gauges, but what goes behind the technology, and how technical this whole process is. I think we got a tip of the iceberg, some information around that. But I think don't miss the next week episode, viewers, when Naveen is going to tell us more about what goes on behind the scene when it comes to technical cables, industrial cables. So Naveenji, thank you so much for joining us and giving us all this information. It was very valuable.
Thanks so much. My pleasure.